Hello class, how are you doing all? Today we'll be discussing about feature engineering presented to you by me, myself and my team. So let's get started. This is the definition for feature engineering, which is a process of transforming raw data into features that better represent the underlying problem to the predictive models, resulting in improved model accuracy on unseen data. And creating appropriate features for learning through massaging current models, which will be removing noise and the normalization, and also combining current features like dimensionality reduction, which will be useful to reduce data burdens, and extracting more relevant features from source data, which is frequency spectrum. This is the typical workflow of whole machine learning process, and the green part, which shows feature engineering, is what we will be focusing on our coming slides, which have features and targets. So, what can you expect from our presentation here? Like everyone says, feature engineering is absolutely known and agreed to be key to success in applied machine learning. And what you're going to discover here is what feature engineering is and what problems it solves, why it matters, and how to engineer features. So let's get started. So coming to why feature engineering matters. So features is nothing but data which have directly influence the predictive models you use and the results you can achieve. So why features matter? Because the better features, the more flexibility we'll be having, and also models will be very simple. If we want results to be very, very better, then definitely we need to build more features in our data. So the main topic in feature engineering will be feature extraction. Let's see what feature extraction is. This is an automatically reducing the dimensionality of these types of observation into a much smaller set that can be modeled. Some observations are far too large in their raw state to be modeled by predictive modeling algorithm directly. Common examples include image, audio, and textual data, but could just as easily include tabular data with millions of attributes. That's simply what feature extraction means. And let's see what feature
Most
construction important
important.
topic in feature engineering. And here you need to manually create features. This requires spending a lot of time with actual sample data and thinking about the underlying forms of problems, structures in the data, and how best to expose them to predictive modeling algorithms. This is the part of feature engineering that is often talked the most about in an art form, the part that is attributed the importance and signaled as the differentiator in competitive machine learning. It is manual, so it's going to take a lot of human brain power, which makes it a big difference. Let's see the example of what this feature engineering does in machine learning. Let's say, for example, date format. Some countries use months in the first, and some countries use dates in the first. Not some countries, most of the non-American countries use date first, then the month. But when it comes to America, it's like month first and the date next. This problem is not straightforward and cannot fed directly into the machine learning models. So, for example, the date can be given either by some formatted string of a text or by a standardized data. The standards and format can vary among different organizations. Let's see, for example, if there's a company and the data displayed in the database were filtered with the days, and let's say there's an error in detecting by giving the month first, then the date. So it's just a simple Python code where we can change it. This is the easiest way to split data into three integer features representing the day, the month, and the year. So I hope this example best fits how we include features in the data.
So the first question is, does feature construction need a lot of human brain power? And coming to the next topic of the PPT, automatic identification of features from a given raw data. The objective of this topic is to automatically learn the abstract representations, either in semi-supervised way or unsupervised way. Representation learning or feature learning is an effort towards this goal. So there are few learning methods which got success in the area, such as autoencoders and restricted Boltzmann machines. And coming to the working pattern of this automatic identification, the abstract representations are prepared automatically, but you cannot understand and leverage what that has been learned. So they cannot inform you and process on how to create more similar features or different features like those that are already performing well in the machine learning on a given problem or on a similar problem in the future. Nevertheless, it is fascinating and exciting and an important and modern part of feature engineering. And coming to the example, motion sensor cameras are the most common example used in this. Motion sensor cameras are used in finding out the inexpensive and unobstructive gather vast amount of data on animals in the wild. Deep learning can automate animal identification for 99.3% of accuracy as per 3.2 million image snapshots, whereas the same data performed with the human volunteers, the accuracy was only 96.6%. And coming to the second question, what are the deep learning methods that are achieving success in the feature engineering?
Hi. So now coming to the iterative process, the iterative process is defined as the process of the interplace with the data selection and also the model evaluation again and again until the time to compute the problem is completely run off. So how this is achieved? So like how the iterative process is done. So this is basically done in 4 methods. That is one is brainstorming features, devise features, select features, and evaluate models. Coming to the brainstorm features, it is nothing but looking into the raw data to select or to study the data, like to extract what features need to be extracted from the data. Coming to the devise features, it depends on your problem to select which features best suit your problem. Okay, so this can be done using automatic feature extraction methods or the manual feature extraction methods. Coming to the select features, it is nothing but it is selection of features based on views like tabular formats, etc. Coming to the evaluate models, it is nothing but estimating the model accuracy of the unseen data using the chosen features. That means, we evaluate our model's accuracy, like by taking the features into play, like what is the accuracy before feature selection and extraction, and what is the accuracy after selecting the feature extraction and all. Now coming to the example, the common example we can see here is the basic better illustration of the tabular data. So if you consider this one, say 2 columns, that is area and cost. If you want to say plot a data, you will not be understanding the relation between the area and the cost. But if you could see the cost, if you add a feature additionally, that is cost per unit, we could better understand the data, like, okay, so because of this cost per unit, the actual cost of the area is being calculated. So that is how the feature extraction or feature selection better gives us a better understanding of how we can well understand the data. Coming to the last and final question, that is the question 3. What is the main agenda for the device features in the iterative process of the feature engineering? The options are as below. So thank you.